Okay, next problem we're going to do is problem 1.4, which is at the bottom of the image here. And that says, write a paragraph describing the particle model. What is it? Why is it important? B, give 2 examples of situations different from those described in the text for which the particle model is appropriate. C, give an example of a situation different from those described in the texts for which it would not be appropriate. Now I'm going to kind of do a little bit of a shortcut here, but I do want to address these points, but I'm not going to do it exactly the way they stated. So first of all, what is the particle model? The particle model basically makes the assumption that we can treat all of the stuff, the mass in an object, as if it's concentrated at a single point. So that's the first thing to remember. Treat the object as if it's a single point. So why do we do that? Well, first of all, you probably noticed that when I was drawing the motion diagrams for problems 1.1 and 1.3, that, well, it took me a while to draw things, and so it's a lot easier just to draw a point. The other thing is that we are basically reminding ourselves that we are going to ignore the fact that it's not uniform and mass isn't all in one point, that sort of thing. So we're simplifying our assumptions about the object. Now, that may not make much sense now, but later in the semester when we're looking at things like rotational motion, it'll make a lot of sense. So we're basically trying to assume the particle has no form other than a point. And this is a simplification. Okay, so that's part one, part A. Part B says, use a couple examples here. So what I'm going to do is I'm going to give you a couple examples where we can use the particle model, but then I'll tell you what we can't use the particle model for in those examples. So this is going to be a kind of a combined B and C, okay? So the first example I can think of is, say you've got somebody who is really excited about Halloween, and they are going to drop a pumpkin off their house, because some people do that. I don't know any of those people, but I'm sure there's going to be somebody who does it. So here's our person here, and they've got a pumpkin, and they're going to drop the pumpkin. So what we're going to do is we're going to use the particle model to demonstrate it being dropped. Now, when something is dropped, it's under the force of gravity, so it's going to be speeding up. So what I'm going to do is, rather than drawing a whole bunch of pumpkins, I'm going to draw dots. So here's our ground. Here's where the pumpkin starts out, right? And initially, it's going to be going pretty slow, so we're going to put a small amount of space between the first 2 positions. Again, this is just like we did before. We're assuming that there's like, frames from a movie or something like that, but we're just drawing the object as a particle. So since it's speeding up as it drops, there's going to be a little bit more space between the first or the second and the third dot. And then of course we're going to get down here and it's going to have sped up a lot, and so the distance between the third and fourth positions is going to be much greater than the previous 2, okay? So we can model the pumpkin being dropped. But what we can't model, so a drawback to this is we can't model anything about the pumpkin spinning. So we can only look at what we call the linear motion. We can't look at the rotational motion. So we can't model a spinning pumpkin using the particle method. Okay. Okay, what about a yo-yo? So here's another example. I'll just these are examples here. We've got 3, 4. Okay, we've got plenty of fingers here. And we've got a yo-yo kind of wrapped around that finger and it comes down here. And we can model the yo-yo going up and down. So yo-yos tend to move at pretty constant pace. So we'll just say that this is going to go down, 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 and then it's going to go back up. Up, 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 up. Right? So we can imagine that it's going to move this way. Sorry, my arrows are not looking very good here. This is not because I don't know how to draw arrows, but sometimes the screen on this is a little touchy, okay? So we can model it going up and down. We can also model around the world. So if we've got the yo-yo, right, and we've got it here, and it's attached, and the yo-yo is going like this, well, we can imagine that the motion is going to go like that, right? So we can model it going like this. Okay? But again, when this yo-yo is moving up and down along the string, it's rotating. So we can't model the rotation on the string. All we can model is how it's moving through space. Okay, so that should give you an idea of the limitations and the uses of the particle model.